So it all starts in the bone marrow, and
Looks like the bone marrow.
Alright, so over here we got hematopoietic stem cells developing into common lymphoid progenitor cells, and then they're going to migrate from the bone marrow to the thymus. We forgot about that.
I can meet the thymus.
You're naturally attractive.
Alright, so when they get there, they are double negative thymocytes. And then they undergo rearrangement of their TCRs, and they become mainly alpha beta TCRs and become double positive thymocytes. And then, so they're moving from the cortex to the medulla, and they're undergoing positive selection to make sure they can bind anything, and then negative selection to make sure they don't bind self too strongly. And then, okay, so the TCR, okay, so the cells that associate best with the MH1 complexes are going to become, oh my god, CD8 cytotoxic T cells. That's so CD4. And then the ones that associate with MHC2 complexes the best are going to become CD4 T helper cells. So, alright, once they have their jobs, they're going to move along to a lymph node. And then they're going to encounter an antigen-presenting cell. So, in order for an antigen-presenting cell to be able to bind, oh, Matt, you can just sit down. Okay, so in order for an APC to be able to bind to a CD4 T cell, it needs to have inflammatory cytokines to tell it to express CD80 or B7. So CD80 is going to bind to CD28 on the CD4 cell. Nice. And then that is going to encourage the CD4 cell to produce NF-kappa B, NF-AT, and AP1. So, those things help the CD4 cell produce a high affinity interleukin-2 receptor, and then it starts to shower itself with interleukin-2. Alright, so the CD4 cell stimulates itself to divide. Alright, after this, CD4 cells can become one of three things: TH1 cells, TH2 cells, or Treg cells. So, alright, TH1 cell development is stimulated by interleukin-2 and interferon gamma, which are produced by the innate immune system. And that encourages, that turns on the transcription factor TBET, which causes the TH1 cell to commit to being TH1. And then that one is going to go activate macrophages using interleukin-2, interferon, and TNF. And then the macrophages of IgG that has been opsonized in the antigen. Alright, so TH2 CD4 T cells are stimulated by interleukins 4, 5, and 6. And they, once it receives those signals, it will turn on transcription factor GATA3. And then that is going to cause it to go to a B cell. And it's the CD40 on the B cell, the TH2 cell is going to bind the CD40 receptor on the B cell and activate the B cell to mount an antibody response, which I think they just did. All right. So the third type of CD4 T cell is the Treg cell. And the purpose of the Treg cell is to turn down the immune response after it's done, to promote wound healing and limit self-reaction. So it's going to go after the T cells with TGF-beta and interleukin. But even though that happens, a small population of these Th1 and Th2 cells is going to remain as a memory population, so that upon reintroduction of the same antigen, it can mount a faster and stronger immune response. So, let's go back to Matt, the cytotoxic CD8 T cell. So, Matt is going to bind an APC in order to activate. But there's three different ways to activate a CD8 T cell. And the first one is just by binding a dendritic cell, like Perry. The second way involves CD4-Th1 cells. So those will combine the same APC, and that will promote CD80 in the APC, which binds to the CD28 on the CD8 this time. And that activates the CD8. And the third way is when the APC tells the CD4 to make a bunch of IL-2 and tells the CD8 cell IL-2 receptors so that it can get that signal that JP has produced to tell it to divide. All right. Next, the CD8 cell will divide and it will go to an inflamed tissue. Like the skin over here, for instance.
Kenny over
Alright,
here.
yeah. It'll go to an
Can you
inflamed
tell by the
tissue.
color? It's red.
And then the CD8 cell will bind. So the cytotoxins, perforin and granulysin, will poke holes in the membranes of the infected cells. So that was you.
Cytotoxin.
So you're poking holes in the infected cells. And then it lets in granzymes, which are serine proteases that degrade a bunch of proteins in the infected cell and cause it to apoptose. And then it also produces cytokines. It also produces cytokines like interferon gamma that help stop viruses from replicating and help them be expressed on the MHC. And INF gamma also recruits macrophages. You're done, you're safe. So just like the CD4 cells, CD8 T cells will go to a low level and create a memory population so that it can do this even stronger next time it's used. That's the end.
All right, so just real quickly, some summary statements here. I want you to remember, and this is an area that some students have trouble with, so with each of these adaptive cell populations, there's a precursor stage from the bone marrow. It's got to travel to the thymus. In the thymus, there's some important developmental stages. Please holster your weapons. Beyond that, you have a movement of those cells out of the thymus to the periphery, where naive cells go from being naive, immature phenotypes to effector phenotypes. So you saw a lot of that occurring in the lymph node, and then you saw the effector phenotype functions afterwards. So for example, in a CD8 positive cell, you're going to have an encounter with an antigen presenting cell as a thymic emigrant. But you're not ready to kill that APC. I think I just misspoke on tape there, but your APC in the lymph node that transitions you from a thymic emigrant to an effector phenotype is not likely the first cell you're going to kill. You're not going to turn around and kill that immediately. You're going to move out into the periphery and re-encounter an antigen-presenting cell which has that same peptide and MHC complex. Then you're going to pull the trigger on your Nerf machine gun and unload that combination of perforin granzyme to kill or ligate the fast molecule. All right, so again, some stage-specific things, and again, I want you to think about this organizationally. We've covered these pieces, and now you get to see them as one longer story. All right, questions? All right, one group remains. Let's take a little break and get you guys set up. All right.
Listen, my children, and you shall hear the crazy story of B.C. McDeer. He was born in the town of Barrow and grew up on the straight and narrow.
Always stepwise development.
After he made it through all the slush,
Maturation steps.
he was lured west by the great gold rush.
Migration to secondary lymphoid tissue.
He made it out west.
Fine, I'll just read it. Secondary lymphoid tissue.
And he got him a gun. On the gun.
DCR binding soluble antigen.
And a knife.
Cytokine receptors.
And some ammo.
Co-stimulation.
And set out for some fun. The last thing he needed was a partner in crime. TH2! Whose thoughts, wants, and needs would with his align. He found old TT just lickety-split! And in no time at all, the two were joined at the hip.
I now pronounce you a cognate pair. You may.
TT taught him all the tricks of the trade
CD40 secretion.
to fight against the robbers
Pathogens.
in the Old West Parade. The pair found the robbers, but they needed some more troops.
B-cell clonal expansion.
So they recruited some boys at the local saloon.
In the B-cell germinal center.
As the pair drank whiskey and beer with the gang, they only kept the ones that could shoot worth a dang. The boys each grabbed a different sort of gun
Somatic hypermutation.
and loaded up many types of ammunition.
Isotype switching.
The fearless leaders, along with their gang, went to see about all of the clang. Lo and behold, down at the bank was a parade of looters all lined up by rank. As BC, TT, and the rest of the boys took out the robbers and all of their ploys, I don't know. BC took note of the faces under those masks, so he would be ready for whatever his next task.
Effector memory cells.
The end.
All right, so I'll go ahead and add a couple of things here. This particular story gives you a lot more of the interplay, and you might have borrowed that TH2 cell from some of the earlier players if you had done that differently. But again, the connection here is to try and think about what happened in the previous segment as it relates to what happened here. And again, the idea of antibody secretion and the presence of that soluble protein is equally as important as the presence of multiple cell types, multiple effector cells in the lymphoid tissue in terms of protective immunity. Okay? Other questions, concerns? All right, let's give this group another round of applause. All right, let me finally say thank you for taking this really seriously. It's a little more staid than some years, but in all seriousness, I really appreciate you buying into this. I hope this was useful for you either on the front end in terms of doing the document or today just having those mental images that you're never going to forget to help you remember some of the details involved. So I do have an evaluation. I would love your feedback about whether this was worthwhile to you, and if you